Hi everybody, and welcome to another JASP tutorial video. Today we are going to be working on correlations, and specifically in the correlation matrix. Before I get started, I want to go ahead and just remind you that we are using the JASP 0.10 preview release for these tutorial videos. So let's go ahead and get started. Okay. So here is a data set that I've been working with in many of my previous videos. It's a data set of real data from real human subjects, and we're going to go ahead and use that data to talk about the correlation matrix in JASP. So you start by going to regression. Correlation is a part of the regression, and here we have correlation matrix, linear regression, and logistic regression. So we're going to go ahead and click on correlation matrix, and it brings up a familiar screen if you've been watching my videos previously or you've had some experience in JASP yourself. So we have all of the functions and options for the correlation here, and then on the left, and then on the right we have the results module. Okay, so I thought for this example I'd go ahead and use my 6 scale variables here, these continuous variables. I have 3 problem types: incongruent, congruent, and neutral problem types on the lawyer-engineer problem, and I have and each of them have 2 DVs associated with them, or 2 continuous variables associated with them. You can see the RT here. This is the response time, average response time for the set of incongruent problems, and a corresponding accuracy score that is expressed in a proportion. And I thought, well, let's go ahead and correlate all of these. Let's put all 6 of these into a correlation matrix. So you can do this a number of ways. You can individually click them with this arrow to the right, and it'll plop that into the variables box. You can drag it over, and when the box turns green, you can just release your click, and it will fall into the box. Or you can click the top one and click hit Control on your keyboard and click another one, and you can put those over. And then finally, I'm just going to go ahead and put them all back over here so I can show you my last trick. You can click the top one, hold the Shift key down on your computer, and then click the bottom one, and what that'll do is it will select all of the variables in the between the first click and the last click, and bring them over to the variables by, you can either drag them, you can click this over to the right, and here we have all of them in here. So here are all of my variables in this box here. Okay, so here you have the Pearson correlation matrix. This is the default way that this this table is shown, and it puts the below diagonal correlation matrix because on the diagonal you would have 1s because it is perfectly correlated with itself, and you would have these values mirrored on the top side of the diagonal. So JASP goes ahead and gets rid of the superfluous extra identical information and just displays below the diagonal. So this is the default selection, Pearson product moment correlation. This is a correlation between 2 continuous variables. These continuous variables are usually interval or ratio scale variables. And the other option that is checked by default is to report the significance value, and that is shown here by the p-value. So we have an R value for each pair, the row and the column, excuse me, and then the p-value associated with that. So we have the Pearsons R value and the p-value for that R, and the n associated with it, the degrees of freedom, which is n minus 2 for Pearsons R. Before I talk about Spearman and Kendall's tau b, I'm going to talk about what these options do for you if you're just trying to do Pearsons R, and then we can jump into what happens if your correlation coefficient requires a different kind of correlation coefficient. Okay, so we have the basic table, R and p-value. For a lot of basic applications of correlations, this is sufficient. It's actually fairly succinct, and it's nice, and it gives you it in a nice, wonderful APA formatted table, which you can then just make a couple of changes to, plop that into a paper, and you're done. It's pretty good. Additional options that will help us if we need a little bit more information. One, if you're doing a huge set of correlations, because you can do as many as you want, it just JASP and other correlation matrix operations and functions and other statistical programs, they'll just do pairwise comparisons all the way through. So you can have, have this correlation matrix be 100 different variables, and you'd have 100 different pairs and a massive table. Now, 100 is an extreme example, but imagine you had a lot. And this turns out to be a lot of numbers, right? So in order to help us out, if we're using the 0.05 alpha level as our null hypothesis criterion, I can go ahead and click flag significant correlations, and what it will do is it will not only give us our p is less than 0.05 with a single asterisk, it will also flag different alpha levels, 0.01 and 0.001. And so in the table, you will have 1, 2, or 3 asterisks for your p-values, for your r's. So the asterisks appear next to the r value, not the p-value, because I can go ahead and uncheck report significance, and here I have an even more compact table where I can flag those correlations. I have a note here that's that has my p-value criteria, and this is generally speaking, this is the kind of table you would find in an APA style manuscript for a correlation matrix, because it has those values. R is really what is important, and flagging that at various levels. You don't need the exact p-values in a lot of cases. So I'm going to go ahead and click on report significance, so just we have all of the options selected. Next, I can display pairwise tables. So instead of a correlation matrix, it will give me a pairwise table. So this is the incongruent accuracy and congruent accuracy with the R and the p-value. So it's another way of showing the correlation matrix, but this is more of a row-based table as opposed to the correlation matrix, which has the pairs in rows and columns in that format. So you can only have one or the other. So if it's unchecked, by default, it's a correlation matrix. If you check it, then it will collapse the correlation matrix into this pairwise table. They both say the same thing. You still have the pairs and the data within those pairs coming up with an R value, and that R value has a p-value. If I uncheck report significance, the only numerical column in this pairwise table are the R's, and then the correlations themselves are flagged. Okay, so I'm going to go ahead back to the correlation matrix. I could also display confidence intervals. This gives the confidence interval for the R value in upper and lower, and you can go ahead and change the percentage. By default, it is 95%. And so if you want to display the confidence intervals for these values, you can go ahead and show them in your table. And in the pairwise comparisons, show you that table. We have R, we have P, and then we have the lower and the upper value of the confidence interval as two separate columns. So again, this just displays the pairwise information, or the pairwise information in another way, depending on how you want to read the data, or what works for you. I think that's a personal choice. Again, without the confidence intervals, again, you tend to see correlation matrices expressed like this in APA style, but nobody's telling you have to do that. As far as the last option, the Vovk-Selke maximum P ratio, apologies if I'm saying that wrong. I am not going to discuss it in this video, as I have not discussed in other videos. It's a specific option if that's something you're specifically looking for, but for these tutorials, base level, we are not going to jump into that level of specificity. Okay, so the last thing we can look at in correlations is correlation matrix plots. So this is rather interesting, as you see my little working arrow here. The correlation plots are coming up. These three dots mean that my computer is working, and then here we go. Here are the correlation plots. Now, if you looked at my descriptive statistics video, link in the top right corner over here at the moment, you would have seen me talk about how the correlation plots are arranged. It's the same here. Now, the x-axes here aren't the greatest because they're all getting smushed, but we don't need to really worry about that. This is mainly for looking at relative shapes, and since we get the regression line, the strength at a moment's glance. And so again, the plots are put in the same orientation, except above the diagonal in this case, below the diagonal for the numbers, numerals, and for the plots above the diagonal. But you still have rows and columns of variables. Okay, and so this gives you all of your plots at once. A couple of options I have for this plot of the matrix is the densities for the variable. And so this will give the densities for the one-to-one comparison. So prior to me checking that box, there was nothing here because there is no way to put a scatter plot for the same value on the y or x-axis. That it would just be a line. And so instead, we can add in here for the diagonal, because it just puts this in the diagonal, as you can see. This is the histogram and density plot. So not only does it give you the histogram, so it's the frequency, but it also gives you a density curve for that. And finally, the statistics. This will modify the correlation matrix plots. Now here we have, this is where the fun of JASP comes in. So the excellent thing about this is not only do we have the correlation matrix expressed as scatter plots with regression lines, we now have taken the value from this table here and put it into the below the diagonal. So the statistics, which is an R value and the 95% confidence interval, you cannot modify that. These are the only two things that you can get. So unfortunately, you don't get the flags for significant values for what they are, but you can, this table gets reproduced no matter what. So you get the R values there and nice big numbers for your correlation plots. So I find this display to be all-inclusive for pretty much everything. Not only does it tell you, well, R is 0.408 for congruent accuracy and incongruent accuracy, right here, see this one? It's a mirror of this one here, okay? So this scatter plot corresponds to this information. So it's pretty good. For the next part of this video, I want to go ahead and talk about the alternative hypotheses radio buttons here. And so what I'm going to do is I'm going to uncheck the correlation matrix box so we have a cleaner display of our correlation matrix. I'm also going to uncheck confidence intervals. And then we'll take a look at how this correlation matrix changes for whatever alternative hypothesis we have decided to choose. So depending on what variables you put in here, your null hypothesis for null hypothesis significance testing might just be that the variables aren't correlated. That is, their values their R values are close to zero, either close to zero on the positive end or close to zero on the negative end. But the fact of the matter is, they're essentially zero. That's expressed by a horizontal line using regression line. All of the dots on a scatter plot are scattered all over the place, and so that's the null hypothesis. They're not related. They're not correlated. And so the default radio button for the alternative hypothesis is that the variables that you put in here are correlated. And so again, this is a two-tailed test. Whatever alpha value we're looking for, again, p is less than 0.05 is the standard in psychology. It might not be the standard else in other fields, but it's the standard in psychology. And so you're looking for R values that will be at or below that p-value threshold. So I'm going to go ahead and hit the correlated positively as my alternative hypothesis. I think all of these things are correlated positively with one another, and this becomes a one-tailed test, as you can see in this note. And another lovely thing that JASP does for this correlation matrix is it also signifies that these asterisks at these levels are one-tailed. And one of the ones that I will point out here is the neutral problem accuracy score and the incongruent accuracy score and their R value. So it doesn't change, still 0.397, but let me go back to correlated for 1 second. The p-value is exactly 0.001. Okay, not less than 0.001 as this value is, but exactly 0.001. That's what happens on a two-tailed test. But when I move the critical value, it becomes more significant. That is to say, the p-value goes lower because I've moved the critical value to a lower, or I should say a closer to the R distribution's mean, because I have 0.05 in the entire in the entire positive side tail. Now, if I decide to do this and say that, you know what, no, my alternative hypothesis is that they're all correlated negatively with one another. And so I end up with a different looking table. So all positive correlations are not flagged as significant, even though on the face of it, the absolute value of 0.408 with this number of data points in this data file does constitute a significant test. But because I said, no, they're correlated negatively, this positive 0.408 is at the wrong end of the R distribution. And so the p-value is 1. And so all the negative correlations now are in the right direction, so to speak, and so those get flagged at the level according to this. And finally, I want to go ahead and talk about the other correlation coefficient options that you have in JASP. So we have the Spearman and Kendall's tau b. So in both of these cases, the data that you plan to use will depend on which one you choose of the three. And it's probably the case that you will be choosing one of the three to do your correlation matrix, not all three. But I can go ahead and check the box here and let you know what the Spearman rho value is for these. I'm going to go ahead and click on alternative hypothesis, so we'll see what happens to the rho value, and then go ahead and throw in Kendall's tau b. In each case, what you get is the correlation coefficient. So here we have R, here we have rho, and here we have tau b. And then you get a p-value associated with each of those. Now, what is Spearman and what is Kendall's tau b? Well, Spearman correlation coefficient is the rank correlation coefficient. It is rho, R-H-O, or the Greek letter that, interestingly enough, looks like a P. Sometimes is referred to as R subscript S to indicate that it's Spearman and not Pearsons R. I'm talking about lowercase r here. And it is the non-parametric test for a correlation coefficient. And so this usually means that you've violated some sort of normality assumption or something else. And generally speaking, it is used to determine the relationship between two variables that have a monotonic function. And the monotonic function, if you're not familiar, generally looks like a fancy wave. Increases very rapidly as we go across the x. Then it has sort of a flat increase and then increases very rapidly at the end of the x scale. I'll go ahead and throw up an image here so you can see what I'm talking about. Then Kendall's tau is specifically for ordinal associations between two variables, and this is specifically a non-parametric test. And so you would use this to determine if ordinal variables are related to each other, which you cannot do with Pearsons R. So Spearman and Kendall, essentially, they give you the same information as Pearson. I can uncheck Pearson here. It gets rid of it from the table, and you end up with a correlation matrix of rho and tau b. Okay, or I can put that back, and you can see. Okay, again, I can display this as a pairwise, and so I get two levels of my columns. I get a Pearsons R and P, I get a Spearman rho and P, and I get a Kendall tau B and P. And just as a side note, tau is looks like a lowercase fancy t in Greek, and so we have a rho and then we have a tau for our other two correlation coefficient statistics. But again, Spearman and Kendall are non-parametric tests. Pearson is parametric. Spearman and Kendall are used in the situation if you have ordinal or non-normal data that you can't use Pearson for. All right, that's going to do it for correlations in JASP. Please leave your feedback and comments down below. Thank you for watching this tutorial video. Bye-bye.